Hello and welcome to Nikolai's genetics lessons, and this video going to be about genetics, law of probability and inheritance. And here's a problem. In men, keratosis, a skin abnormality, is due to a dominant factor. A man with keratosis whose father did not show the abnormality marries a woman with keratosis whose mother was free from it. And here's the two questions. Question A: if they have 3 children, what are the chances that all 3 children will show a condition? Before I will show you how to solve this problem, I want to show you this picture, and this is example of keratosis. And usually keratosis can be found in young children, teenagers, or old people. So keratosis can be just like shown here on this picture. This is not life-threatening condition. This is just caused by buildup of the keratin protein in the skin, overproduction of the keratin, and sometimes it looks like chicken skin. But there are different types of keratosis, and some of them can be carcinogenic. For example, you can see some of such examples in the man who is bald, and the scalp, if a person is pretty old, may also show up such spots that is different color, and sometimes can be also raised above the skin. And that type of keratosis needs two factors. First factor is genetic. You have to get it from your parents, and the second factor is environmental. It would show up only if those body parts would be exposed to solar radiation. So about 10% of that keratosis can become carcinogenic. So let's now return to our problem. We have a man with keratosis. We know that this is dominant genetic disorder. We know that his father did not show the abnormality. So let's build a pedigree for his family. Here is his mother. Here is his father. We know that his father didn't show this abnormality. So in order for this person, he's a male, so square, in order for him to be affected with this genetic disorder, he have to inherit it from his mother's side. So that means his mother have to be affected. So she has to have a dominant allele that she passed to her son, and another allele he got from his father, so small a here. So we know that this person, a man with keratosis, heterozygous for this trait. You may ask, how do we know that his mother is heterozygous also and not homozygous dominant? We just assume that this is rare genetic disorder that show up when one dominant allele present, so it is not necessary to have two dominant alleles, and this would be very rare event. So both parents of this female have to have this genetic disorder in order for her to be homozygous dominant. So we just assume that she just has only one dominant allele. So what we know about female, so this male marries a woman with keratosis whose mother was free from it. So let's build another pedigree. So mother were free from it. So that female got this condition from her father. So here is a female that also has this condition, and that means that her mother is homozygous recessive and her father is heterozygous, and she also got this dominant allele from her father and recessive allele from her mother. So now we know the genotypes of both these people, and now we can build a Punnett square, and we can predict the probability for the progeny to inherit this genetic disorder. So let's say, so this is male and this is female. So let's this side would be female side, so she is heterozygous, capital A, small a, and this side would be male side, and male genotype is also heterozygous. So when we build a Punnett square, we can predict probability for the progeny to be affected with this genetic disorder. So here we have capital A, capital A, capital A, small a here, and small a here. As you see, 3 out of 4 would inherit this genetic disorder, and only 1 out of 4 would be phenotypically and genotypically normal. So once again, probability that the children would be affected is 0.75, and probability that the children would be normal regardless of the sex would be 0.25. So now we can solve question A. If they have 3 children, what are the chances that all 3 children will show the condition? And probability that the first child would show this condition would be 0.75. Probability that the second child would show this condition also would be 0.75. And probability that the third child would be affected with this condition also would be 0.75 chances. So because this is all independent probabilities, we use rule of multiplication, and our answer here would be 0.42. Or if you need an answer in percentage form, we just have to multiply this number by 100 or move this decimal point 2 places to the right, and the answer would be that probability is 42%, that all 3 children, so child number 1, child number 2, and child number 3, all of them would be affected. Probability is 42%. And now question B, if they have another child, what are the chances that this child would be a girl who will not have keratosis? Every time when this family conceive a child, they have the same equal probability to have whether a boy or a girl. So 50% chances that they would have a girl and 50% chances that they would have a boy. So chances that the next child would be a girl is 0.5, and chances that this girl would be genotypically normal is 0.25 or 25%. So this is 2 independent probabilities, so we have to multiply them, and the answer would be 0.125. Or once again, if we need an answer in percentage form, we have to multiply by 100 or move this decimal point 2 places to the right, and the answer would be 12.5%. So 42% our answer for the question A, and 12.5% is the answer to the question B. And one more note, would our calculations be affected if we would know that, for example, mother of this male would be homozygous dominant? We know that this person is affected, so he got one dominant allele from his mother. We know that his father doesn't show this genetic disorder, so he have to be small a, and he can get from his mother only one allele, and he got dominant allele. We already know this, so it doesn't affect our calculations if we would know if she is heterozygous or if she is homozygous dominant, because this is already event that happened. We know that this person is affected, so it doesn't matter whether his mother homozygous dominant or heterozygous. We know for sure that he is heterozygous because his father phenotypically normal, and that means he has two recessive alleles, and one of them he passed to his son. And the same picture is here. It doesn't matter whether father of this female is heterozygous or homozygous dominant. We do not calculate chances here because it is already known fact that this female is affected. So she only can be heterozygous because her mother is phenotypically normal. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any. And see you in the next video. Goodbye.